All right, welcome everyone. Today we have a major topic. We're going to do section 5-4. Two things. One, we're going to do the area of non-right triangle. What's another name for that? No, that would be a wrong triangle. Math humor. And we're going to do the law of sines, okay, which is really cool. It will help us also to find angles in non-right triangles. So this is big. This is good. So, uh, as Zach showed us, what formula do we use for area of a right triangle? Or I shouldn't say that, area of any triangle. Area of any triangle is 1/2 base times height. And as I was bugging Zach, we have to have A equals. But in this case, we're going to call the area K. And I'll get to that in a minute. K is the area because we're going to have another A, and I don't want to confuse the two. So we're calling area K. So K equals 1/2 base times height for any triangle. So far, so good? Good. Now, let's get a triangle and a good one this time. Not one of those lame triangles. We need a good triangle. Something like that. Yeah, not just any. You deserve the best triangle. All right. I still don't like it. It's got to be perfect. I still don't like it. I'm going to flip it. Flip it good. All right, now I'm starting to feel it. There we go. Good triangle. Now, so let's label this. Here's that A I referred to earlier, and here's B, and here's C, and then opposite of A, what do we call this side? Lowercase a, lowercase b, lowercase c, and then just for funds, and because we can't quite do the area yet, we said that K equals 1/2 base times height. We have the base. What's the problem? Yeah, we don't have the height yet, so let's, as I said to Zach with Shannon, the girlfriend from Hood River, if you can't find a friend, make a friend, right? When you're heartbroken, make a friend. That's it. And let's kind of remind ourselves that B is the distance out here, like that. It's all the way, now that we have two triangles. And of course, we're going to call this new line H because it's the height. So far, so good? So now we've got area of this triangle, ABC equals 1/2 B base times H height. Questions? Casey, is that all right? Casey, Oregon State? Okay, right. So now, but wait, there's more. What about if I said, we're doing law of sines, right? So what about if I said sine C, what would that equal? Sine C, what would that equal in terms of letters? Opposite over hypotenuse. We better check it. Sure could tell. Oscar had, sure enough. Opposite over hypotenuse, which in this case would be what? Ooh, Timothy, you crazy. H over A. But remember, we put this H in on purpose to be a right triangle, so we have to use H because this stuff here, sine, cosine, tangent, only works for right triangles, okay? Sine C equals the length of H over the length of A. So far, so good? Okay, now we can do some tricks. Riddle me this, Batman. What does H equal then? Claire. Louder. A times sine C. Notice Crazy Claire said times A times A. Yeah? And she's right. And the A's divide out and become 1. And so H equals A times sine C. Intriguing. Now, give me some kind of mad color. Purple? Or is that fuchsia? Okay, so check this out. Now I can say K equals, is anyone psychic? 1/2 times B times, yeah. I'm going to put that in parentheses so you can see it. A times sine C. Because that is the same as H. All of that. We substitute it in by substitution. Woo, you're doing some heavy math, everybody. Does it make your brain hurt? Not that bad. So K equals 1/2 B times A sine C. And normally you're going to see this area of non-right triangle. K equals 1/2, and they always say it like this, AB sine C. And that is a theorem or corollary or a postulate or something. Area of a non-right triangle, we're calling it K, equals 1/2 AB sine C. And again, just like with the law of cosines, Yahira, we can do this. These don't have to be A's and B's. You can do it for any triangle, but you have to have two sides in the included angle. Any triangle, two sides in the included angle. This could, not that. This could be A and B and C, big C. Or it could be, what if this were big A? What would it look like? Yeah, that would be B and that would be C, and you'd say the area equals 1/2, then what? B, C, sine angle A, like that. See, so it works. It doesn't have to be in this exact order, okay? And then what would the other one be? Area equals 1/2 AC sine B. Good. Because, let's be honest, it's the same triangle. The area doesn't change. Area of this triangle and this triangle, they're all the same. Okay? So that is really, really useful. Totally. Totally. How are we doing on time? I better keep going. But you'll have some examples of this in the book. This is all in the book, but it's a little confusing, so this time I wanted to show you. So yeah, we have this same triangle. I wonder if I can clone this. Okay. I'm going to bring this down. We're going to do part 2 of the lecture. Not that. There we go. It's okay. I don't need them. Don't need them, and actually I don't want them. Okay, so we have this triangle. No matter how we label it, the area is the same. Do you agree? The stuff on the inside is the same. I wonder if I can fill that. Properties. Solid fill. Okay. This blue area here is the same no matter how we label it. Agree? So I can say 1/2 AB sine C is equal to 1/2 BC sine A is equal to 1/2 AC sine B. Is that craziness? Okay. So let's do some nuttiness now. This looks wild. We don't normally have two equal signs, but this is a little different. Let's clean this up. How would you start by cleaning it up? We want to make it better. Heaven, what do you think? Yeah, how would you clean this up? Busted. It's okay. Everybody's tired this week. I want to try to simplify this, Heaven. It's too busy right now. Yeah, what are like terms? You're right. What are like terms? What's the easiest low-hanging fruit like term? The halves. So let's just divide everything by half or multiply by the reciprocal 2. It doesn't matter. Okay? Same thing. Okay? Then, what does that leave me with, Heaven? No. Yeah, look at it. What's 1/2 divided by 1/2? Not nothing. Nothing would be 0, which is my hero. In this case, it's not 0. It's 1. Yeah, that divides by that becomes 1. And that divides by that, and that becomes 1. And that divides by that, and that becomes 1. Okay. So, Heaven, back to you. What's left? So, AB sine C equals, hang in there, everybody, we're almost done. AB equals, sine C equals BC sine A equals AC sine B. Sweet, we're almost done. You're off the hook. Who am I going to pick on that I haven't? Marco, I haven't beat up on you in a while. I think it's time to have some math abuse. All right, go for it. We're going to try to simplify this some more. I would. I would I would divide this by A and B. I would divide this by A and B. And I would divide this by A and B. Okay? I would. But you know how they get, Marco. It's like little sisters. Hey, wait! They got divided by A and B. They got divided by A and B. They got divided by A and B. You know, they get like that. Yeah, all of them. And that's important. So what do we have now? Now we have sine C equals, ooh, help me out here. Be careful. What happens to the B's? They divide out, cancel. The A's divide out. We have sine C equals C sine A over what's left? Little a equals C sine B over little b. This is pretty good, Marco, pretty good. I only see one problem here. I only see one problem. You're actually very good, but we have one more step to clean up. No, A and B are good, actually. This is fine. Those nasty little C's are annoying. They're like that zit that won't go away just before your big date. Hate it when that happens. The worst. How can we get rid of the C? No, clear a cell. Yeah, divide by C, and divide by C. You're right. Okay, so now we have sine C over C equals sine A over A equals salud. Bad time to get allergies, huh? Or is that a cold? I don't know either. Okay, and this, and normally you'll see it written just sine A over A equals sine B over B equals sine C over C. And that, ladies and gentlemen, is where we get the law of sines. Okay, and again, you'll have lots of time to practice. How are we doing on time? Oh, we're not doing too bad. The one note I want to say is you only use 2 at a time. Only use 2 at a time. Some people try to use all 3 and it makes them crazy. Note 2, use when you know any 3 components, I'll say. Okay? Notice, if you're using 2 at a time like these, there's 1, 2, 3, 4 components. If you know 3 of them, you're home free. Let's do an example of that. Okay? Let's do an example. I need any kind of a triangle, and then I need, give me this angle down here, call it A. What's this angle? How much? 29, sure. 29, and give me this over here. Give me a distance. Somebody else? 4 what? Centimeter. Thank you. And then we need one other thing. Let's call this B. C. Give me an angle down here. Boring. No, too big. Reasonable. Yeah, that's not bad. Okay, we'll go 45. Okay, so we can say, and again, you just need 2 at a time. We can say sine A over A equals sine B over B. And then it's just a proportion. One fraction equals another. Okay, so then we have sine A is the sine of how much? 29 over what's A? 4 equals sine of 45 over little b. But you're right, x would work, and that's fine. And then all you got to do is solve that. All you got to do is solve that. Everybody solve that real quick. Is that us? Oh my gosh. Okay. Notes tonight. Tonight, notes and questions and examples on 5-4. Thanks for your kind attention. Wow.